Welcome. Today we'll be considering variation under the subtopic inverse variations. Okay, please for the introduction of this class that is under variation, please check my previous lesson under the introduction of this variation. Okay, welcome. So I said that variation is just simply defined as a relationship between two or more quantities in part 1. So over here in part 2, we are going to focus mainly on inverse variation. Okay, so what is inverse variation? Simple. Inverse variation describes a specific relationship between two quantities where they move in opposite direction. Okay, this shows when one quantity increases, the other decreases. Okay, good. All right, so before we proceed, thank you. Hi. I would like you to just use few seconds to share this live class so that others can also benefit, please. Okay, before we solve more examples. All right, now in inverse variation, like specific example, distance and speed. The higher the speed, the less time taken to get to your destination. Good. All right. Now, mathematically, you notice that x varies inversely as 1 over y, so that x will be k over y. Okay, x will be k over y. Now, if you have something like this, our k is called constant of variation. Okay, while this is symbol of variation. Now, I'm going to show you how to establish the relationship, or you call it the law of variation, in any problem. Okay, symbol of variation using this k. All right, before we proceed, please, I would still like you to share this live class. Share it. Okay, share the live class so that others can benefit. Thank you. Kindly subscribe. And then like. Thank you. All right, let's solve examples. Let's proceed to solve examples here. So remember what I said here. Inverse variation describes a specific relationship between two quantities where they move in opposite direction. Okay, so let's solve examples. Remember, we are dealing with inverse variation. Okay, let me use this. All right, so example here. I have if y varies inversely as x, okay, and y equals 6 when, hope you can see it properly, when x is equals to, find y when x is 3. Solution. All right, according to what I said when we are talking about inverse variation, first, you will now have y varies inversely 1 over x. So remove this symbol and introduce a constant so that you can have y is equals to k over x. Now make k the subject formula. Make k. All right, so that k is equal to y x. Now substitute. When you substitute, you have, what is the value of y? See it here, 6. The first value, you write 6 multiplied by the second, the value of x here is 2. This is equals to 12. So we have k, therefore k is equals to 12. Now, to establish the constant of, to establish the relationship or formula for variation, substitute this k into y equals k over x, okay? So I will have y is equals to 12 over x. This is what is called a law of variation, or we call it formula connecting the relationships, okay? Formula connecting the quantities. All right, so we are going to use this formula to solve any other problem, like as we have here. Find y when x is equals to 3. So we'll proceed. To find y at x equals 3. So you just have y is equals to 12 divided by x, so that I can have 12 over 3. This is equals to 4. So y is equals to 4 at x, okay? At x equals 3. So ask your question. That's how to solve it. Like I said, when you have inverse variation, it's a simple thing. Just remove your variation symbol, introduce a constant. So this is your constant. Find the value of the constant, which is 12. Use this 12 and substitute back to this place, okay? Substitute it back to this y equals k over x, so that you have your relationship. Use this your relationship as a formula to solve any other problem, okay? Like we can now ask, find the value of x when y is 1 over 2. Let's solve. Now find y at x equals 1 over 2. Okay, that is I add. So what we are going to have here is, recall is equals to 12 over x. at x equals 1 over 2. So you have that y is equals to 12 over 1 over 2. This is 12, okay, multiply by 2 all over 1, which is 24. So what if you are required to find the value of x, okay, when y is equals to 4 over 3. Good. When y is equals to 4 over 3. So see what you can still do. Recall is equals to 12 over x. So substitute here as 4 over 3 is equals to 12 over x. So you can easily cross multiply to have 4 times x is equals to 12 times 3. So that you can have x is equals to 36 divided by 4. Okay, so that is what you're going to have at x equals 4 over 3. So we can look at so as at x equals at y equals 4 over 3, x is equals to 9 when y is equals to 4 over 3. Remember this is 9, okay? Alright, let's proceed again to solve more examples. We still have here as inverse variation. Good. Example 2. Alright. So assuming you have m varies, that is p. Okay, let's go with x. X varies inversely as 1 over y, so that and x is equals to 5 while y is 12. Let's go like this. Okay. Question now is find x at y equals 20. B. Find y at t equals, let's go by, okay, 40. Find y at x. Where is x, not t? Alright, solution. Given x varies inversely as 1 over y, x will be equal to k over y, so that k will now be x multiplied by y. This will give us 5 multiplied by 12. Okay, this is 60. So put it back. We are going to have x is equals to 60 over y. This will be your relationship. Or call it formula. Good. So the number one question here said find x at when y equals 20. This is simple. So x 60 over y, you have substitute 60 over 20. So what is the answer? This is 3. So at x equals 3, y is what? 20. Then we have here find y when x is 40. So I can have x is equals to, remember, is 60 over y. So when you substitute the value of x, which is 40, is equals to, hope you can see it, 60 over y. Okay, therefore y is 60 over 40. Therefore y is what? This can go and this will go, 3 over 2. So that is the value of y. Excuse me. When x is 40. So this is how you can solve problems on partial, on inverse variation. Okay. Now ask your question before I will give you an example. Excuse me 1 second. Ask your questions. Now we have class activity here. Or can we solve more? 1 or 2 examples here. Example 3 before I'll give you class work. P varies inversely as x and y is 4 when P varies inversely as, we are going to use consistent letters P and Q, okay, and P is equals to 4 when Q is given as 1 over 2. Let's go with that. So find the value of Q when P is equals to 10. Solution: P varies inversely as Q. P is K over Q, so that K equals P Q, which is 4 multiplied by 1 over 2. We have 2 here. So P is equals to 2 over Q. This is our formula now, or relationship. Hope you're with me. Do you have any question? Good. Let's proceed. So to find Q when P equals 10. To find Q when P equals 10. It's simple. Just put, say, to find Q at P equals 10. So I'll put 10 here. I'll substitute 10 here equals 2 over Q. So that this is invisible when cross multiply. Okay? Cross multiply. When you cross multiply, you have 10Q is equals to 2. So that Q, hi, welcome. Q will be 2 over 10. Therefore, Q is 1 over 5 at P equals 10. So that is how you can solve this. Now, what if you are required to find the value of Q? Find Q. We'll find Q the other time. So let's find P when Q is equals to 1 over 4. All right. Okay, when it is 1 over 4. So I have P equals 2 over Q. Good. At Q equals 1 over 4, you have P is equals to 2 over 1 over 4. So this 4 can come up. You have 2 multiplied by 4 over 1. Therefore, P is equals to 8 when Q is 1 over 4. Alright? Now solve this. So let's consider this exercise. Given that m raised to power 2 varies inversely as 1 over n. When m is 5, n is given as 6. Okay? Find m when n is 3. So solve and share your answer in the comment section, okay? So solve this and share in the comment section. So solve. What is your value? So solve. So what is the value? What is the value? Okay. Kindly subscribe. Thank you. So find M when N is 3 and share your answer in the comment section. Alright, so find the value of M, find the value of M when N is 3, find the value of M when N is 3. So what is the value of M? What is the value of M? Thank you, thank you, thank you, thank you. So for M when N is 3. Remember, you can see what I have solved here. Okay, good. You can see all the appropriate methods that I have used. So use the same method and solve for M. Okay, let's solve. Solution. You have M squared varies inversely as 1 over N, so that I can have M squared is 1 over N, okay? K over N, okay? M squared is K over N. So that K will be M squared multiplied by N. Now K is, our M is 5 raised to power 2 multiplied by 3. So you have 25 times 3. So you have your K at 75. But they said find M when N is 3. Look up. So our M here will be, remember, go back to this place to have your K, which is 75 now, over N. This is our relationship that I have posted like this. Now to find our M, I don't want to open another page. Let's just finish everything here. Find M. m, please, this is m squared. So m squared is equal to 75 over what? Where is your n? What is the value of n? Oh god, oh god, there is a little mistake here. And our n is 6, so we have 6 here. Okay, please, sorry, this is 6 here. Okay, so that you have your 25 times 6. Okay, this is 6 again. You have 150. So this is what we are going to write here. 150 over n. Good. So m is 150 divided by our n. What is the value of n? N is 3 now. Do you see when I realized that small mistake we made? 3. So that you have m, remember is square, is equal to, now what you're going to do here, observe here that this is m square, not m, so that your m will be plus or minus square root of 50, okay, which is 5 root 2 and 8 basic form. Okay, so that is the value of m for, that's the value of m. So I hope you have gotten what I've done here. All right, so have a glimpse of it again before we call it a day for today. Then our next class will consider joint variation. Okay, consider joint variation, which is the combination of both direct and inverse. Then subsequently we'll look into partial variation. Okay, partial variation is when one quantity is partly constant, the other one the same, the other one partly varies. So we have two constants in partial. In joint variation, we can have both direct, or combination of direct and inverse. Good. So just stay tuned. Okay, in our next class we'll consider it. Now in this particular question, what if I ask you to solve for we solved 2 problems here. We solved 2 problems already. Solved 2 problems. So please go through it again. Go through it once again and ask me a question so that we can consider the problem. So go through it and ask your question.